Hi, this is the unit on chemistry and water. This is Ms. Vitale, AP Biology teacher at Summit High School. This unit on chemistry corresponds with Chapter 2 in the textbook. In order to study biology, you need to understand key concepts of chemistry. All organisms function and survive based on chemical reactions that occur in their cells. Organisms are composed of matter. Matter is anything that takes up space and has mass. Matter is made up of elements. Elements are a substance that cannot be broken down to other substances by chemical reactions. There are 92 elements that occur in nature. If we look at the periodic table, each element has a symbol. The first or second letter of the name, and the name could be in English, Latin, or German, designates the symbol for the element. For example, sodium has a symbol capital N lowercase a because natrium is Latin for sodium. A compound is a substance consisting of two or more elements combined in a fixed ratio. Sodium chloride is table salt. Sodium by itself is a soft volatile metal. Chlorine is a poisonous gas. However, when you combine them, you get a compound that we consume and is relatively harmless to us. Life requires about 25 chemical elements. As you can see from this chart, some of them are displayed. 4 of these elements, carbon, oxygen, hydrogen, and nitrogen, make up 96% of living matter. Trace elements like calcium, phosphorus, and potassium are required by an organism in minute quantities. However, that does not mean that they are not essential for life. Each element is made of a specific type of atom. The smallest unit of matter that still retains the properties of an element is an atom. They are so small that it would take 1 million to stretch across the period at the end of a sentence. Atoms are made of 3 types of subatomic particles: protons, neutrons, and electrons. The atom's nucleus contains the protons and neutrons. The electrons orbit around the nucleus, almost at the speed of light. Electrons have a negative charge, protons have a positive charge, neutrons have a neutral charge. The protons and neutrons are found in the nucleus. The electrons orbit around the nucleus in space. All of the mass is in the nucleus. The mass of a proton or a neutron is 1.7 times 10 to the minus 24th grams. This is too small, so we actually call it a Dalton. Therefore, 1 proton or 1 neutron equals 1 Dalton. Electrons are about 1/2000th of a Dalton, so we ignore them. The atomic number on the periodic table is equal to the number of protons. Therefore, it is also equal to the number of electrons. The number of protons determines the element. The mass number, or the atomic weight, is in Daltons, and it is the number of protons and neutrons. In order to determine the number of neutrons, you subtract the atomic number from the mass number, and that gives you the number of neutrons. All atoms of a given element have the same number of protons, but the number of neutrons can vary. These different forms are called isotopes. An isotope is one of several atomic forms of an element, each containing a different number of neutrons, therefore differing in atomic mass. Carbon has 3 common isotopes, C12, C13, and C14. All have 6 protons. Radioactive isotopes is when the nucleus is unstable and it tends to break down or decay, releasing beta particles, which are electrons speeding away from the nucleus. Radioactive isotopes have many useful applications in biology, like PET scans and radiometric dating for fossils. If the nucleus of an atom was the size of a golf ball, the electrons would be about 1 kilometer away, or over 3,000 feet away. Atoms are mostly empty space. Electrons vary in the amount of energy they possess. The negative charge of the electron is attracted to the positive charge of the proton. The further an electron is from the nucleus, the more potential energy it has. Potential energy is stored energy. Energy levels, or electron shells, represent different states of potential energy that electrons have. The first shell has the lowest energy. The first shell can hold a maximum of 2 electrons. The second shell can hold a maximum of 8 electrons, and the third a maximum of 18 electrons. The atoms that are most common in organisms have less than 18 electrons, so we don't really have to go beyond the first 3 electron shells. However, when you get to chemistry, you will. The chemical properties of an atom are determined by the electron configuration. Mostly the valence electrons. Valence electrons are the number of electrons in the outermost shell, or the valence shell. If the valence shell is full, the atom is unreactive or inert. It won't interact with other atoms. Electrons move around the nucleus in orbitals. Orbitals are 3D spaces where electrons are found, 90% of the time. Orbitals have no more than 2 electrons occupying them. Reactive atoms are trying to pair unpaired electrons and have a full valence shell. In chemical bonding, atoms with incomplete valence shells interact with certain other atoms. These interactions result in the atoms staying close together, held by attractions called chemical bonds. A covalent bond is a sharing of a pair of valence electrons by 2 atoms. Covalent bonds can also be double or triple. A molecule, therefore, is 2 or more atoms held together by chemical bonds. Electronegativity is the attraction of an atom for the electrons of a covalent bond. More electronegative atoms pull the pair of electrons in a covalent bond towards itself. Polar covalent bonds are electrons of bonds that are not shared equally, like in water. Non-polar covalent bonds are when electrons are shared equally, like in hydrochloric acid or hydrogen gas. Ionic bonds occur when electronegativity is so unequal, one atom strips an electron from its partner. In this case, sodium has 1 electron in its outermost shell. It wants to get rid of that so it can go down to a full valence shell with 8 electrons. Chlorine has 7 in its outermost shell. It needs 1 to complete the 8. So sodium is stripped of its electron. Chlorine takes it. Because sodium is now missing an electron, it takes on a positive charge. And because chlorine has an extra electron, it takes on a negative charge. An ion is a charged atom. A cation is an ion with a positive charge, like sodium. An anion is an ion with a negative charge, like chlorine. Therefore, an ionic bond is the attraction between an anion and cation. And whenever ionic compounds are formed, they are called salts. A molecule has a characteristic shape and size. The precise shape of the molecule is very important to its function in a living cell. Most biological molecules recognize and respond to another based on shape. For example, signal molecules released by brain cells fit together on receptor molecules on other brain cells, stimulating activity in the second cell. This is one way the brain cells communicate and signal each other. Some drug molecules have similar shapes to the signal molecules that your body produces and can affect mood and pain perception. For example, morphine and heroin mimic natural endorphins. Chemical reactions are the making and breaking of chemical bonds. In this chemical reaction, the H2 and the O2 are the reactants, and the H2O is the product. The numbers in front are the coefficients. Because you have to have an equal amount of each type of atom, on both sides, in the reactants and the products, because matter is conserved in a chemical reaction. Reactions cannot create or destroy matter. Photosynthesis is the following. 6CO2 plus 6H2O yields C6H12O6 plus 6 oxygens. So you have 6 carbon dioxide molecules and 6 water molecules that create 1 glucose molecule and 6 oxygen molecules.